most of that in the brain. We store about a day's supply of glucose, most of that in the form of glycogen, a little bit floating around as free glucose in the blood. You can see from these numbers that there will probably be times when you don't have enough. If you didn't eat anything for a day, you burn through this, what's your brain going to be doing? Your body is set up to have a backup system to make glucose if you're not consuming enough carbohydrate in the diet. And this process of making it is called gluconeogenesis. The making of glucose, not from other sugars, but from non-carbohydrate precursors. So if there's dietary restrictions, you might be doing gluconeogenesis. The other place you'd be doing it is post-exercise recovery. We talked about during strenuous muscle exercise, you ramp up glycolysis in tissues that are going anaerobic, so you just go crazy doing glycolysis, that little bit of substrate level phosphorylation, you're trying to live off that, so you burn glucose at very high rates. Lactate is the fermentation product that accumulates, it's in the tissues, it goes to the bloodstream, it's all over the place. The liver will try and rebuild that lactate into glucose once you stop that strenuous exercise. So lactate is not a carbohydrate, it's a non-carbohydrate precursor to rebuild glucose. It's not just lactate, lots of amino acids and glycerol and pyruvate can all be converted to glucose. The one thing, I always thought this was a human failing, we can't convert our fats into glucose. Other organisms can, I don't know why we can't.
We can't, but didn't you say like as a